In the second part of this tutorial, we're going to take two shapes that are now each moving at random speeds each time between 0.5 and 5 pixels per frame through draw, so 60 times a second. And we're going to check to see which one of them crosses a finish line first. So again, each of these two ellipses have a speed variable that uses the random function to get that random value between 0.5 and 5, and a starting location of 50, so they will start 50 pixels over on the x-axis. Then we add each of their independent speed variables to their old locations to get the new location each time the program loops through. So this is sort of the race portion. So down here we'll do the finish portion. The first thing I need to do is make the finish line. So we'll say maybe 450 pixels over, 0 pixels down to the top of the screen, to 450 over, and 500 pixels down. Next, I want to see if that blue ellipse gets to be at the same point as the finish line. So I can do that with a conditional statement. If x, the location of my blue ellipse, gets to be greater than 450, then you can have some sort of feedback like text. Player 1 wins. I don't know, maybe 200 over, 50 down. Close the conditional, or close the curly brackets for that conditional. And then if we'll do the same thing for player 2, x2 gets to be greater than 450, text, player 2 wins. Same place. Close the conditional statement by closing that curly bracket. Make sure you still have your curly bracket closing draw. The one problem with just using text here for the first time in a conditional is there will be a little bit of lag as it loads the default font, but that's nothing you can do about that except load a font file. So it looks like red is going to win. We're going to get a little lag. It's going to say long lag. Oh, player 2 wins. Oh, and then player 1 wins. I guess, oh, I did not put 50. That says 500, so I'm going to change this one to 50. So even though player 2 won first, or actually won, and player 1 lost, they both came up because there's no way to stop the second conditional from being called, even if the other shape, quote unquote, wins first. So what you can do is add into each conditional a way to make sure that doesn't happen. So there's two things you could, well, there's a bunch of different ways you could do this. There's two we're going to look at. One is you could just send that shape back to the starting line and just set its position back to 50. So if I could say if x, player 1, wins, then I'm going to say x2 equals 50. So it goes back to the finish, or back to the starting line rather. Same here. I'm going to say if player 2 wins, I'm going to set the x position of player 1 back to start. To eliminate the lag, we can actually just maybe put a little title in here so the font will have already loaded. Let's say text race game, racing game. So now the lag is going to come at the beginning. So player 2 is going to win, and as soon as player 2 wins, player 1 is reset back to the beginning. The other thing you could do, it's not necessarily better, it's just a different approach. If you want the loser to just stop wherever they are on the, our little racetrack here, you could just set that speed to 0. So instead of setting its location back to the start, you could set the speed to 0. So in this case, it would be speed 2 equals 0. Down here, it would be speed equals 0. So, and as we saw in the last video, if you're adding a speed of 0 to a location, you're not going anywhere. So a slightly different approach. But either way allows just one of the ellipses to win. So.